Jupiter is almost too big to put into words. It's about 1,300 times the volume of Earth. You could fit every other planet in the solar system inside it and still have room left over. Its gravity could crush you in seconds. There's no surface to stand on, no solid ground, just a giant continuous gas storm that's been raging since before humans, before dinosaurs, before life on Earth even existed. But the question we're answering today isn't, could we live on Jupiter? The answer is simply no. The real question is, if we actually tried to descend into it, how far would we get, and how long would we last before the planet destroyed us? Today, we're not just looking at Jupiter from a distance, we're going in, layer by layer, kilometer by kilometer, until we find out exactly what's down there, and why no spacecraft humanity has ever built has survived the trip. Before we descend, we need to understand the scale of what we're dealing with, because numbers like 1,300 times the volume of Earth don't really mean much until you see them side by side. Jupiter's diameter is about 143,000 kilometers. If Earth were the size of a grape, Jupiter would be roughly the size of a basketball. Its mass is about 2.5 times the combined mass of every other planet in the solar system put together. In fact, Jupiter is so massive that it doesn't orbit the exact center of the Sun. The Sun and Jupiter actually orbit a shared point of gravity called a barycenter that lies just outside the Sun's visible surface. And yet, for all its size, Jupiter spins faster than any other planet in the solar system, a full rotation in under 10 hours. That means the cloud tops near its equator are moving at over 45,000 kilometers per hour just from the planet's own spin. This rapid rotation is actually one of the reasons Jupiter's storms behave the way they do, stretching bands of clouds into the striped pattern we recognize instantly from photographs. If you could approach Jupiter in a spacecraft, the first thing you'd notice is that there's no clear line separating space from the planet. Jupiter is made almost entirely of hydrogen and helium, the same elements that make up the Sun itself, just not massive enough to ignite and become a star. Scientists sometimes call gas giants like Jupiter failed stars for exactly this reason. The first layer you'd enter is the upper cloud deck, frozen ammonia crystals that create the planet's signature brown, orange, and white bands visible from Earth. The white bands are called zones. The darker orange-brown bands are called belts, and they flow in opposite directions like massive interlocking conveyor belts of gas, driven by Jupiter's fast rotation and internal heat. The temperature here is around minus 145 degrees Celsius, and wind speeds can reach 600 kilometers per hour, far stronger than the most powerful hurricane ever recorded on Earth. In an ordinary spacecraft, those winds alone would tear you apart within minutes. And here's something most people don't expect. Jupiter has lightning too. Enormous bolts far more powerful than anything on Earth, striking within the ammonia and water ice clouds. Some of these super bolts release energy hundreds of times greater than an average lightning strike on our planet. If you tried to avoid the polar regions and pass near the equator instead, you'd run into something called the Great Red Spot, a storm larger than the entire planet Earth that has been raging continuously for at least 350 years, possibly much longer, since it was first documented by early telescope observers. Winds inside this storm spin at speeds exceeding 430 kilometers per hour, and any spacecraft attempting to cross it would be torn apart instantly. Unlike hurricanes on Earth, which weaken over time as they pass over land and lose energy to friction, this storm has no landmass to drain its momentum, so it just keeps going for decades, for centuries. Interestingly, data from recent missions shows the Great Red Spot has actually been slowly shrinking over the past century. 100 years ago, it was wide enough to fit 3 Earths side by side. Today, it's closer to 1.5. Scientists still aren't fully certain why it's shrinking, or whether it might eventually disappear entirely, the way a smaller, similar storm on Jupiter did in the past. Here's the part that makes this whole thought experiment even more chilling. Humanity has actually sent something into Jupiter's atmosphere before, and we know almost exactly how far it got before it failed. In 1995, the Galileo spacecraft released a small atmospheric probe designed to descend into Jupiter and radio back data for as long as it could survive. The probe deployed a parachute and began transmitting readings on temperature, pressure, wind speed, and composition as it fell. It lasted just under 58 minutes before the extreme pressure and heat destroyed it. And by that point, it had only descended roughly 150 kilometers into the atmosphere, a tiny fraction of the distance to anything resembling a core. Engineers believe the probe was likely crushed, melted, and possibly vaporized shortly after transmission stopped. That's the sobering reality. Our best real-world attempt didn't even get past the upper cloud layers we just described. Everything from this point forward in our video is based on physics models and extrapolated data, not direct measurements, because nothing built by humans has gone deeper and survived to report back. The deeper you go, the atmospheric pressure increases at a terrifying rate. At around 350 kilometers below the cloud tops, pressure reaches more than 10 times Earth's sea level atmospheric pressure. The human body simply isn't built to withstand pressure like this. Even the deepest diving submarines on Earth, rated for the crushing depths of the Mariana Trench, operate at far lower pressures than what exists at this point inside Jupiter. Any solid object, a spacecraft, a human body, would begin to deform and fracture under the mounting force. At the same time, temperature starts rising in a way that feels backwards to anything we're used to on Earth. The deeper you go into Jupiter, the hotter it gets, not colder, driven by the immense pressure and the planet's own internal energy. In fact, Jupiter radiates more heat into space than it receives from the Sun, a leftover signature of the enormous gravitational energy released when the planet first formed billions of years ago. Assuming, hypothetically, a spacecraft could somehow keep descending, a scenario that's practically impossible, it would reach a bizarre stage. Hydrogen, which was a gas near the top, gradually transforms into a liquid state under the immense pressure, without ever passing through a clear, freezing point the way we'd expect on Earth. There's no traditional surface here at all, just a gradual transition from dense gas to dense liquid with no clear boundary line. Imagine diving into an ocean with no surface you can point to, the pressure around you constantly increasing as you sink, the sky above you slowly thickening into sea without ever announcing the change. By this stage, temperatures have already climbed into the thousands of degrees Celsius, and pressure has grown to millions of times greater than Earth's. Some scientists believe this hidden layer might contain oceans of liquid hydrogen stretching for tens of thousands of kilometers. Technically the largest ocean in the solar system, just not one made of water, and not one any living thing could ever visit. Here we enter one of the strangest regions in the entire solar system: liquid metallic hydrogen. Under pressure exceeding millions of times that of Earth's atmosphere, hydrogen atoms start behaving completely differently. They lose their electrons and become an electrical conductor, like a metal, despite still being in a liquid state. This layer is responsible for the most powerful magnetic field of any planet in our solar system, roughly 20,000 times stronger than Earth's. Jupiter's magnetosphere, the region of space controlled by that magnetic field, is so enormous that if we could see it with the naked eye from Earth, it would appear larger in our sky than the full moon, despite being hundreds of millions of kilometers away. A compass here wouldn't behave normally at all, and the magnetic radiation in this region alone would fry any electronics within seconds. This same magnetic field is also why Jupiter has such intense radiation belts so powerful that they're a major design challenge for any spacecraft, like Juno, that dares to orbit close to the planet. Juno's electronics are protected inside a specially built titanium vault just to survive repeated close passes. Temperatures here can exceed 10,000 degrees Celsius, hotter than the surface of the sun in some regions. Before we go any deeper, it's worth pausing to remember what we'd be leaving behind on the way in. Jupiter has at least 95 known moons, but 4 of them, Io, Europa, Ganymede, and Callisto, are worlds in their own right, first spotted by Galileo Galilei over 400 years ago. Io is the most volcanically active body in the entire solar system, constantly reshaped by the tidal forces of Jupiter's gravity. Europa is hiding a liquid water ocean beneath its icy shell, one of the most promising places in our solar system to search for life. And Jupiter even has a faint ring system made of dust kicked up by micrometeorite impacts on its smaller inner moons, far fainter and less famous than Saturn's rings, but real nonetheless. All of that complexity, all those worlds, are quietly orbiting a planet with no surface at all. A planet so violent that everything of true interest actually happens around it, not on it. For years, scientists believed Jupiter had a small, solid core made of rock and metal, similar to a rocky planet like Earth, just much smaller. But data from NASA's Juno spacecraft, which has been mapping Jupiter's gravity field with extreme precision since 2016, revealed something different. Jupiter's core isn't fully solid, and it doesn't have sharply defined edges. It's better described as a massive, diffuse, fuzzy core, extending far larger than expected, gradually blending into the layers of metallic hydrogen above it, rather than sitting as a distinct ball at the center. Some scientists believe this fuzzy structure might be the result of a massive collision early in Jupiter's history, when a large planetary body could have slammed into the young planet and partially dissolved into it. So even if you theoretically made it to the center, you wouldn't find ground to stand on in any conventional sense. You'd find extremely dense, extremely hot material, potentially reaching temperatures of over 24,000 degrees Celsius, hotter than the surface of the sun, under unimaginable pressure, arranged in a way unlike anything found on any rocky planet. Jupiter might be one of the most hostile places in the solar system for any living thing that tries to approach it. But ironically, it's also our guardian. Thanks to its immense gravity, Jupiter pulls in or deflects the path of countless comets and asteroids that might otherwise be heading toward Earth, acting like a giant natural shield for our planet. In 1994, the world watched as fragments of comet Shoemaker-Levy 9 slammed directly into Jupiter, a dramatic reminder of exactly this role, and a preview of what could happen to Earth without a planet like Jupiter absorbing so many of these impacts first. In other words, the one planet where life is truly impossible turns out to be one of the biggest reasons life on Earth was possible in the first place. It's a reminder that even the most hostile places in the universe can play a vital, quiet role in our own existence, protecting us from a distance we can barely comprehend. If you enjoyed this journey into the largest planet in our solar system, subscribe to the channel and let me know in the comments, which planet should we descend into next? I'll see you in the next one. Let's get there together.